when you go to your screen, double click on the MATLAB icon, or you go to start and double click on the MATLAB icon, then you will get the command window or the MATLAB window. The MATLAB window looks like this. Now on this, as I told you, there are various windows in MATLAB. The bottom one here is the command window. Some computers it is organized in a manner that it can be the top one. We have already seen how to make it top one. Simply drag it to the top position, then it will be the top one. So the bottom one is the command window, which has two greater than signs indicating that you are at the command prompt. So these two greater than signs, they indicate the command prompt. It is the command window. Above that is the program window, what I call program window. There you can write program. A program is, as I told you, a combination of or a sequence of MATLAB commands that forms a program, MATLAB program. So if you write anything in the program window and store it, then it will be stored as a .m file. File name you have to give. You will give a name to the file, so then it will stop. Then it will store. It will be stored as the .m file. On the left hand side, you can see that it is the current directory. So in this directory, what are available, which are the programs available, which are the files available, everything can be seen in the left hand side. Right hand side shows you the command history. So whatever command we are giving, those command history will be on the right hand side. So this is basically a short description of the MATLAB windows that we have seen in the last class. Now let us go to details of command window. So if we go to the command window, in the command window what we do is we type our command. So to type a command, take the cursor, almost the moment you open the command window, your cursor will be blinking near the command prompt. So if it is not blinking there, then you move your mouse near the command prompt and click there. So it will be there. That is what is called the placing the cursor next to the command prompt. Then you write whatever command you want to give there. So after this command prompt, write the command, then press the enter key. So that command will be executed. You can also give several commands in one line or in many lines. So if you give several commands in one line, then those commands will be executed one after another. After you give the commands, all the commands, then you have to press the enter key. Then those commands will be executed in order one after another from left to right. Now suppose you have given a command and you want to recall that command. One command you have given, after that you have given 5 commands. Then you want to get back the first command. So for recalling the command, always you can press the up key. So arrow key, up arrow key, keep on pressing till you see the command that you want to give or which you have already given earlier. That command will be displayed on the side of your command prompt. Then you can press the enter key, and if you want to modify that command, there you can modify that command after it is displayed, but before pressing the enter key. So after you press the enter key, you cannot do anything. It will be executed. Similarly, you can use the down arrow key to move down the list of previous commands. Up arrow key takes you up the list in previous command. Down arrow key takes you down the list in the previous commands. So this is a brief on command window. We will continue on that. Suppose you are writing a command. You are writing a command which is very large, or you are writing a list of commands which is large. So it may not fit in your screen. In that case, you have to write 3 periods. So as you approach the end of the screen or as you approach the middle of the screen, I write 3 periods, which also we call ellipses in English. So put a ellipse and then press enter. it will go to the next line, then there you keep on writing this command. So if that is also filled, then put 3 ellipses, go to the next line, keep on writing. So this you can do for about 1800 characters. This can be continuous. Sorry, 4096 characters. This can be done. A command can be, or a sequence of command can be up to 4096 characters at a time. So after that, you have to renew this or write a new command. So this is continuing the command. Then let us look at the command history. What is command history? Basically, MATLAB keeps the record of commands used in the command window. And if you write CLC command, CLC is a command, clear the screen. CLC is clear the screen. So your screen will be cleared. Whatever is written on the screen in the command window, that will be cleared, not other screens. Only the command window will be cleared. So this clears the command window only, but it keeps the history. History is not clear. So after that, you can use your arrow keys, up arrow key or down arrow key, to retrieve the command. Okay. Now if you want to transfer the command, so for transferring command from the command history window to the command window, you have to use up arrow key or down arrow key. Then once it appears in the command window besides the command prompt, then you can press enter. Otherwise, what you can do is you can straight go to the command history window. There you will see the commands are there, the commands that you have already used, earlier used. Choose the command that you want to use, go to that point, move your cursor onto that command, then double click on that command. If you double click on that command, that will be executed. Otherwise, you can also do another thing. You can select that single click, drag it onto the command window, and in the command window you can enter it, press enter, it will run. If you are writing a program, from there single click and drag it to the program window, then in the program window it will be pasted. You will paste it, so it will be automatically there. So this is the facility which is available in MATLAB. This is not available in any other programming language. So this is the beauty of. Now let us see what happens in the workspace of MATLAB. I am going to give you some examples here. If you have MATLAB with you, you can run these and test these whether these are correct or not. First, look at the left hand side. In the left hand, look, there is a command prompt. After the command prompt, there is 3, then there is great sign, then there is 2. 3 great sign 2, or 3 # 2. So that means 3 to the power exponentiation of 3, or 3 to the power 2. So 3 is the number which will be exponentiated, 2 is the power 2 which it will be exponentiated. So 3 to the power, then if you put enter, if I click enter, then MATLAB will give me ANS is equal to 9. So 3 to the power 2 is 9, so I get answer as 9. Similarly, if I write A is equal to 8, then press enter, MATLAB will give me A is equal to 8. Now what is the difference between these two? In the first case, 3 to the power 2 is not assigned to any variable. So MATLAB takes by default ANS as the variable. So it will be ANS is equal to 19. In the second case, the variable is A. We have given A as the variable. Therefore, MATLAB will assign the value 8 to the variable A in the second case. Now in the third case, B is equal to 4 numbers. We have given 4 numbers in one row. Row means it is from left to right. Column is from top to bottom. So in one row, we have given 4 rows which are separated by commas. 1, 11, 111, 1000, 111. 4 numbers are there. So if there I click the enter sign, now you can see that B is equal to square bracket starts, then the 4 number, then the square bracket end. After the square bracket end, if I click the enter sign, then it will show B is equal to 111, 111, 1111. Now in the second line there is no square bracket. In the first line there is square bracket. Near the command prompt there is square bracket. That means when you are entering a matrix, you are entering a row or you are entering a column, then you have to give the square bracket. That is for the user, but the computer or the MATLAB will not show the square bracket. It will show it in a line separated by space, from which you have to understand that it is a row matrix. Similarly, C is equal to, you can see 1, 2, 3, semicolon 4, 5, 6, semicolon 7, 8, 9. And there is a square bracket. So within square bracket, these numbers are there. Then if you press enter key, then the MATLAB will show you C is equal to 1, 2, 3. Next line will be 4, 5, 6. Next line will be 7, 8, 9. This means that if you separate a set of number or an array from another array by a semicolon, those will be in two different rows. 1, 2, 3 is one row, 3, 4, 5, 6 is another row, 7, 8, 9 is another row, and each row is separated from the other by a semicolon. And each row has 3 columns here, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now from this, the moment you have run this command in the command window, you will see that on the workspace, which is on the right hand side, top one, you can see it shows workspace. On the workspace, it shows you name of the variables A, B, C, and ANS. Then the value of each variable is given, minimum value of the variable, maximum value of the variable, everything is given in the workspace. So you are running a command or you are giving a command in the command window, immediately the result you can see in the command window as well as in the workspace window. So in both the cases you can see it. Now in the workspace below that you can see that it shows name, value, size of each variable. Size of A is 1 cross 1 matrix. It has only one row and one column, so it is a 1 cross 1 matrix. B has one row and 4 columns, so it is a 1 cross 4 matrix. C has 3 rows, 3 columns, 3 cross 3 matrix. ANS has 1 column and 1 row, 9 is 1 column and 1 row, so it is a 1 cross 1 matrix. So that is what it shows. Then it says how many bytes it takes. Remember that for 1 cross 1 matrix, it takes 8 bytes. 1 cross 4 matrix, it will be 8 into 4. 1 cross 1 matrix is 8. So for 1 it is 8. Then multiply it by 4, that gives you 32. 3 cross 3 is 3 cross 3 into 3 is 9. 9 into 8 bytes is 72. Similarly, 1 cross 1 is 8 matrix. All these are class is double. Either these are double or integer. You can see that these are all double. By default, it takes it as double. MATLAB takes them as doubled. Then you can use, there are 2 more commands. One is called who command, other is called whose command. If you write who after this command prompt, write who, WHO. Who means who are present, which are the variables which are present. So it will write your variables are A, B, C, ANS. So since we have used 4 variables, the names of those variables is given. If you write whose, then it will write A, B, C, ANS. Then below that, the description given above in the workspace, those descriptions for those variables will appear below A, B, C, and ANS. So this is something about workspace window. Now let us look at how you are going to use MATLAB. Always MATLAB operates or uses the file which is available in the current window. Right? This is called the current folder. How to find out the current folder? Once you open the MATLAB window, on the left hand side you can see the workspace. In the workspace it is written current folder, which is encircled by blue. So that shows the current folder. In that folder, this is the folder where you are, and in that folder the files available, folders available, everything is shown below that. The ellipse, below the ellipse the folders, below them the files, or the file that you are using can be also seen in the above, which is enclosed in red ellipse. So that is highlighting the folder, exact path you can find from there. That path is C/program file /MATLAB /R2018B/bin. Now you can change this directory. If you want to write the program in another directory, you can always change the directory. So go to another file, another folder, go to workspace. In the workspace you can always change the folder. So go to change folder. From the change folder, go to the folder where you are going to write. So write there, then make that the current folder. So this C program file MATLAB, that line will change automatically. That will become the current folder. You write your program there, store your program there, then you can run your program there. Otherwise, if you write the program in one folder and run it in another folder, MATLAB will be confused. Any computer in any programming language, they will be confused. They cannot correlate, because you are searching for something which is in another room. You are searching in one room, whereas your thing is in another room. Your object is in another room. So you will not find it. So it cannot be executed. So for execution, you will search it in the room or in the box or in the location where the object is. So in that location it has to search. Therefore, your current folder must hold your file or your commands has to be in the current folder. So this is a brief about current folder, why you should use current folder, and how you can use current folder. Now let us come to the document window. In the document window, you can go to the workspace, and the workspace you can always see. If you click on A, suppose here it is A, B, both are seen in the workspace on the left hand side. So if you press on A, that workspace will open on the right hand side, and you will see that it is like a spreadsheet, or it is like an Excel sheet where the values of A are available in a tabular form. Similarly, if you click on Y, or this is X and Y. So if you click on Y, then the values for Y will be available on the workspace window. So this is what is document window. If you want to use those values or any one of those values, you can copy it from there and you can paste it on your program or in the command window and use that value. So this is the process is actually, you can double click on any variable listed in the workspace window. That will launch the document window, and the document window will contain the variable editor. There you can store the values. Values are stored in the variable editor. They are displayed there as in a spreadsheet format. That can be edited, changed, copied, everything you can do from that variable editor. So I hope you have understood up to this point. Now let us go to the graphic window. In the graphic window, so we are discussing different types of windows in MATLAB. So now finally we are coming to the graphic window. In the graphic window, you display a graph. So if you are writing a plot, so suppose in the last three lines you can see in green we have written x is equal to, within square bracket we have given values of x from 0 to 2 pi. So 0, pi by 4, pi by 2, 3 pi by 4, pi, 5 pi by 4, 3 pi by 2, 7 pi by 4 and 2 pi. So these are the values of x for which you have to find out y. Y is equal to sin x. Then you give the command plot xy. So that will we have how many points? X has 1, 2, 3, 4, 5, 6, 7, 8, 9 points. So since there are 9 points, you can see that this figure is not very smooth. It is like joining the points one by one. so it is not very smooth. But that giving the plot command, plot xy command, opens a new window in which you find the plot. So that is, this is about the graphics window. Details of graphics window we'll discuss when we'll do or when we'll come to the graphics using MATLAB, but this is basic. So you can always try this, play with this graphic window. Now we are through with almost all the windows that are available in MATLAB and which you will find for your use at some point of time. Now let us come to the variables that we are using. Always when you are using a variable by the name, name says variable, vari means change. So the things that you assign to something that can be changed. You can write a is equal to x plus 2. Now as x changes, variable a will keep on changing. A is a variable, x is a variable. You keep on changing x, a will keep on changing. Right? So this is why this is called variable. Now how to give a name to the variable? Always assign a unique name to the variable. When you are writing a program or when you are writing a command, always assign a unique name to the variable. It should always start with a letter. Then it can have any number. It is case sensitive. It can be of any length, but MATLAB considers up to 63 length. After that 64 onward will be neglected, but you can give more than 64 characters to the variable name. So don't worry about that. You will not require that lengthy name for giving a variable. You will at best give 4 to 5 characters you will use throughout your programming in this course. And these names are case sensitive, which means if you assign little x is equal to 5, capital X is equal to 8, then you write y is equal to little x plus capital S, x, it will give you 8 plus 5, which is 13. So you will get a return as 13. It will not take capital X. Capital X will not take the value of little x. Automatically that is not done. They are separate. So names are always case sensitive. The characters that are allowed are the letters A to Z, all small letters, then capital letters, all are allowed. Numbers 0 to 9 are allowed, and the underscore. So you can write x underscore 2 or x underscore y. So that is also a allowed variable name. Do not use built-in functions like sine, cosine, log. These are all built-in functions. Do not use the built-in functions as variable, because you, without knowing, you will use the variable sine as a variable. Then you are going to use sine as a function. The program will be confused whether to use variable or to use function. Therefore, do not ever use a built-in function. Now, how to know whether it is a built-in function? You are choosing a variable or giving a variable name, and you want to know whether it is a built-in function or not. So that you can do using, there are many methods of doing that. You can write which then give the name of the variable. If you give which, the computer will show you which are the variables that you are using. Names of the variables that you are using will be shown by the MATLAB. If you write the command each var name, ISVAR name, each var name, this means is the variable name available. So if you write is var name, this will check the allowed output. So is var name, then you write the name of the variable that you are trying to use. So is var name, then the variable, then put enter. It will, the computer will return you 1 or 0. If the computer returns you 1, then the variable that you have written after is var name can be used. If it returns you 0, then it cannot be used, or it indicates that don't use it. Then there is another command which is called is keyword. So if you can write is keyword, then you give your variable name, then you press enter, then the MATLAB will check whether this is a keyword in MATLAB or whether this is an inbuilt function in network. For example, if you write is keyword then space COS then enter, it will show that cost is a variable name. Cost cannot be used as a variable name. It is an inbuilt function that you will see immediately there. So these are some tips on using variables. Now once you know this, and in the last class we had discussed about the precedence rule. So let me give you a test, or let us take a test now. Okay. The first question is, which of these following represents, if I write at the command prompt a is equal to 1 plus x minus 3 star y within bracket slash square root within bracket x plus log within bracket y slash y crate or hat 3 slash 4. So this is what we are writing. This one represents which of the following two formulas? Z is equal to 1 plus x minus 3y by root x plus log y by y to the power 3 by 4, or Z is equal to 1 plus x minus 3y by root x plus log y by y cube whole divided by 4. These are the two formulas given. Which of the formula translates into the above? Okay, so we got two correct answers now. Similarly, this is left to you as an exercise, these three commands. Write a command for each of the following: 1 minus cos pi divided by e to the power minus z plus 3z minus 4 plus on log natural 2.6 into 10 to the power minus 4 z. So write a line or write a command for execution of this one. So this will be one command. Second one is gamma is equal to the right hand side. So for gamma, you know, as I told you, in the variables you can use letters, capital letter or little letter, and then numbers and underscore. Gamma does not come under the letters. So for gamma you have to write GAMA. If you want to write it completely, you can write GAMA, or you can write G, or you can write capital G, whatever you like, you can write for that. Similar the last one, G is equal to sign of something plus a value plus log of something. So this is given, these are given. You have to write the programs for this, and by the end of this class or when we take the break, you have to show us whether it is correct or incorrect. That we will evaluate at that time. Now after we do this, now let us come to the arrays, an introduction to array in MATLAB. The fundamental unit of data in MATLAB is array. That is, this is what is array in MATLAB, because as I told you, MATLAB comes from matrix laboratory. So since matrix is always a combination of arrays, a proper combination of arrays, therefore this array is fundamental unit of data in MATLAB. Data is organized in rows and columns always in the MATLAB. So you will have arrays. A row is an array, column is also an array, so you will have arrays there. Scalars are always arrays of one row and one column, like 8, 7 that we saw earlier examples. 8 is a scalar, so it is a one column one row matrix. Vectors are arrays with one dimension. Usually these are column matrix, but they can be also row matrix. We will see examples, but vector will have only one dimension, which means it will be either a 1 cross m matrix or n cross 1 matrix. That will represent a vector. Matrix is array with more than one dimension. It can be 1 cross 1, it cannot be 1 cross 1, it can be 1 cross 2 or 1 cross n, or n cross 1 or m cross n or m cross n cross p. So it can be of any dimension. Size of an array, that represents the number of rows and number of columns. So if you have got an n cross m array, it shows that there are n number of rows and m number of columns. Rows comes first, columns comes the second. So n cross n or nm array always represents n rows, m columns. Remember this, n rows, m columns. But when you are representing a particular element from the array, it is the opposite. First will come the column number, then will come the row number. We'll see that in an example. Then total number of elements is the product of n cross m. So total number of elements in a matrix is product of n cross m. N into m will always give you the total number of elements available in the matrix. These are certain things which you are expected to have read in linear algebra in your college days, pre-college days, and we are just refreshing this. Okay. Now let us try to work out with matrix. So let me give a scalar. As I told you, a scalar is a 1 plus 1 matrix. Let us take C as a scalar. C is a scalar quantity, so C will be a 1 plus 1 matrix. We can write C is equal to 5.66. That is the value of the C that we are assigning to C. So you can write as C is equal to 5.66, or you can write in the matrix form C is equal to square bracket start 5.66 square bracket n. Both these are correct forms, and both these are equal. They represent the same number C, which is a scalar number. Now if I want to write a row vector, which means there will be only row, there will be no columns. There will be only columns in one row. It is a row vector. Then you write example is x is equal to 3.5, 33, 20, 33.22 and 24.5. These numbers are separated by comma. You can use comma, you may not use comma. So you can use either space or comma. That we'll discuss later. So this is a X matrix is now, it is a row vector and it has 3 elements in the row, which means 3 columns and 1 row. Therefore X is a row vector or 1 cross 3 matrix. Similarly, X1 is a column vector. It has 1 column and 4 rows. 2, 5, 3, minus 1 are the rows and 1 column is there. So X1 is a column vector, or it is called a 4 cross 1 matrix. 4 represents the number of rows, 1 represents the number of columns. So 4 cross 1 matrix. Similarly for X, 1 represents the number of rows, 3 represents the number of columns. Finally, we see a 4 cross 3 matrix, which is A. A is equal to 1, 2, 4, 2 minus 2, 2, 0, 3, 5, 5, 4, 9 within square bracket. So if you are putting A like this, A is a 4 cross 3 matrix. So when you are working with matrices, please remember this is how you are going to represent a row vector, a column vector, or a matrix, or a scalar. Okay. Now let us take it one step further. You can use space or commas for separating the elements of rows. Like here I have given one example, 1, 2, 3, 4 with space, or 1, 2, 3, 4 within the square bracket. Both are within square bracket and both are same. There is no difference in them. For the columns, you can always use semicolons. Semicolons always separate columns. Space or commas, they separate rows. So 1, 2, 3, 4 semicolon means it is one row, 1, 2, 3, 4. Then we'll go to the next row, 5, 6, 7, 8 semicolon. So again you go to the next row, 9, 8, 7, 6. So this is how you will represent columns and rows in a matrix when you are working with matrix. Now let us come to the indexing, which is important and which you should be very careful when you are using matrices. M cross n matrix, it has m rows and n columns. We are saying this repeatedly. It has m rows and n columns. Individual elements of a matrix, Aij or Ai, j, both Aij within bracket within bracket means within the circular bracket. A within circular bracket I comma j, that represents the generalized element in the matrix. Now what does that mean? Generalized element means this is the ith column and jth row. So Aij represents the jth row, ith column. Compare this with and contrast this with the matrix. M cross n matrix. M is row, n is column. Aij, j is row, I is column. I is not row, j is not column. It is just opposite. So when you are using this on the generalized element, I is the column. Which one appears first is the column. Which one appears last is the row. So I is the column, j is the row. For example, A 4, 1 is equal to 5. That says that it is the first row and the fourth column of the matrix A. In the matrix A, the first row and fourth column is 5. That is what is meant by A41. A41 says that it is the first row, fourth column, and the value is given after the equal to sign. For example, A is equal to, within square bracket we are writing 1 2 4 5 semicolon 6 3 8 2. So this has how many rows? 2 rows. And how many columns? 4 columns. So this is a 4 cross 2 matrix. So that is correct. It is a 4 cross 2 matrix. But what is A12? Now it is a 4 cross 2 matrix. A12 means 2 is the row. So second row, first column. What is in the second row, first column? In the second row, first column is 6. Therefore, answer is 6. 1 2 4 5 is the first row. 6 3 8 2 is the second row. In the second row, first one is 6. Therefore, answer is 6. Similarly, you can always use a colon operator, which is very important in MATLAB. So you have to be very careful when you are using colon operator. You can always use a colon operator to index a range of columns. For example, if I write A 1 colon 3 comma 2. Now what does this mean? A 1 colon 3 comma 2. This means that 2 is the row and this means the first 3 numbers in the column, or column 1, first column. This will be 1 colon 3 1. I have written it wrongly. It is not 2, 1. 1 colon 3 comma 1. That means the first row and first in the first row, first 3 columns. In the first row, what we have? 1 2 4 5, and the first 3 columns are 1 2 4. So 1 2 3 means 1 2 and 3. So 1 2 4 1 2 4 are the first 3 numbers in the first row. So 1 colon 3 comma 1. This should be 1 colon 3 comma 1, not 2. So make a correction there. And now let us expand it furthermore. You can always you can use specific elements of any matrix by overwriting using the matrix index. For example, A, and that we saw earlier, 1 2 4 5 6 3 8 2. Now write A12 is equal to 9. A12 is equal to 9 means 2 is the, what is 2? 2 is the row number, 1 is the column number, which means in the second row, first column will be 9. Now if you look at the example, A is equal to 1 2 4 5 6 3 8 2. Now in the second row, first column is 6. Now the moment you write A 1 colon 2 is equal to 9, 6 will be replaced by 9. So answer now will be A is equal to 1 2 4 5 9 3 8 2. 6 has been replaced by 9. So this is something that you can do the moment you want, or if you want to change any element within the matrix, you can always give the element number, which is element index number. If you do the proper indexing for the index number, then change it, give the value, appropriate value, it will change it. Okay. So with this, we'll take a break. With this ends the lecture 3, third lecture, and we'll take a break of 2 minutes and come back for the last lecture. B is on the.